Hi, it's Miss Reese, and I'm going over the Unit 5 test review. So I am going to be going back and forth between Edulastic and the PDF version, which if you want to, you can print out as well, that you can reference. It just makes it easier for me to actually mark up the diagram. So looking here for problem 1, we are trying to determine why the triangles are congruent. And so these are our options: side, 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 angle, side, angle, side, angle, 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 side, or we call it HL, right HL, because it needs to be a right triangle in order to use hypotenuse leg, and then not enough information to prove congruent. So essentially not congruent. All right, so in our first diagram, we've got, I'm going to use, let's say pink for angles that are marked. So here's a congruent angle marked to another congruent angle. And then we've got another set of angles that are congruent. And then I'm going to use blue for this congruent side that is marked here. Okay. Now I know it is between two options. I know it has to be angle, angle, side, or angle, side, angle. There's two angles that are marked, and there's one side that's marked. Now the way I tell the difference is here's the side that's marked. I'm going to trace that full side here. And if that full side, when I trace it, connects to both of the angles, it's in the middle. But because when I trace this side, it does not connect to both of these highlighted angles, it would be angle, angle, side. So that's question 1, angle, angle, side. And you should be able to click check answer as well, but if you're watching this video, you can just use the video to check your answer. Okay, so question 2 here, we've got a right angle, a right set of congruent angles. I'll mark that with pink. And then we've got our congruent side marked here. And then these triangles also have that shared common reflexive side. So I'm going to add a side marking here for that as well. Now, two ways when I look at this problem. This could be HL because it's a right triangle, or this could be side angle side, depending on where the angles and sides are located. So here's my angle, here's my side, and here's my side. So remember that the angle is not in between, so this one can't be side angle side. If I were to put this in the proper order, it'd actually be side side angle. Oops, side side angle does not prove congruent. So I've checked those two things, and then the last thing you're going to want to check is, well, if this is a right triangle, could it be hypotenuse leg? So let's check if it's hypotenuse leg. Well, this side here, this is a hypotenuse in the right triangle. It's across from the right angle here. And this other side, the reflexive side, is a leg. So this is actually hypotenuse leg. So we can put in our solution here, hypotenuse leg, right hypotenuse leg. All right, question 3. We've got our angles marked there, so I'm going to put my angles marked in angle. This other angle would be congruent to it as well, this angle here. And then we've got this side that they both share. We call that the reflexive side. So I'm going to add the congruent mark in the middle. Now, if you notice, when that side is highlighted, it actually connects to both of those angles. So my options are between these two up here, angle, side, angle, or angle, angle, side. And I would say that it's angle, side, angle, because that side that's congruent is in between the angles. So number 3 is angle, side, angle. Okay, so on to number 4. I call these my bow tie questions. Anytime you see triangles that look like bow ties, we are going to mark the angles that are vertical congruent. So I'm going to put a vertical angle mark here and here. And remember, vertical angles and reflexive sides, it's really the only thing you can add to the diagram without having like written out given information to you. So we've got here our angle that's congruent to this other angle, and then we've got our two sides that are marked here, two sides. And if I were to trace those two sides, so these two sides here, you're going to notice that that angle is in the middle of those two sides. So that would be side angle side congruency for number 4, side angle side. Angle is in the middle. Okay, number 5, what we've got here, we've got an angle with 1 mark, with another angle, we've got an angle with 2 markings, and then we've got our angle with 3 markings. Okay, we have no side marks. So if we have no side marks, we don't know if these triangles are congruent. We need some congruent sides. So we could say not enough information. So based on the information that they have now, we can't necessarily say they're congruent. And like if you wanted to give a reason for that, you could say something like angle, angle, angle does not prove congruency. You also need a congruent side. Not enough information. Number 6 here. Oh, that looks like just a rotated version of number 3. They've got this common shared side here, and we've got the 2 angles on either sides of those. That's going to be angle, side, angle. That's number 6. For number 7, it actually looks like question 4. The only difference there is that there's a right angle symbol in this corner. So that means this is vertical to it and it would also be a right angle. Oops. And then the sides that are marked there are not the same as they were in that question number 4. So let's take a look. So we've got an angle that's marked. We've got a side here. We've got a side. So typically I would say, okay, well, the angle is not in the middle, so it's not side angle side. Doesn't work. The angle would have to be here in order for it to be side angle side. That would be the angle that's in the middle. And remember, side angle doesn't prove congruency. Doesn't work. So then my last thing that I want to check then is making sure, okay, well, is this a right triangle? And is there a hypotenuse and a leg? And this is a hypotenuse. And this is a leg in the right triangle. So this is HL for question 7, hypotenuse leg. A right triangle HL. Question 8. We can add the reflexive congruent mark here, put a 1 mark. And then what we have is an angle marking, a side marking, and a side marking. Now, if I were to trace both of these sides here, you notice the angle is not connected in the middle of them. It would need to be located on the other side in order for this to be side angle side. So it's not side angle side, angle's not in the middle. And we know side angle doesn't work to prove congruency. These also aren't right triangles, so I can't check for HL. So there's not enough information to prove that these are congruent. So question 8, we got not enough info. Oops, 9 is a repeat. 10 is a repeat here. Okay, so the next one here, we've got side angle side marked, or sorry, the markings here, we've got a side congruent to another side, and we've got this angle here that's marked, and then we've got another side. So if you were to trace both of those sides, I'm going to trace this side here, and I'll trace this side here. The angle is in between them. It's in the middle. So this would be side angle side congruency. And then I'll just do the last one on here as well. They have a shared common reflexive side as well. So this right here is a side marking, this is a side marking, and this is a side marking. So these triangles are congruent because of side congruency. Okay, so we'll add our solutions for number 9 and 10 onto Edulastic. So 9 was, remember, side angle side, and 10 was side, side, side. Okay, so moving on to question 11. For these questions here, we have some given information that needed to be added to the diagram, as well as some information that's already on the diagram to begin with. So what we're noticing here is we have congruent sides that are marked. We also have the reflexive side. So you always want to look for reflexive sides or vertical angles because you can add those marks to the diagram without given information. Now the other piece to this is that we have a bisector and we're bisecting angle ABD. So here's ABD. It's the angle that's at the middle of that is actually going to be equal. So it's these two parts here that are going to be congruent. So adding those marks to the diagram, even if you're just drawing this on a piece of paper, would be helpful. You will have to, there will be some problems on the test when you're going to add markings to the diagram. So then we can say, okay, we've got our side marked here and another side marked here, and then we've got an angle that's marked. And if I were to trace out both of those sides to the angle, it actually connects to both sides. So this is congruent because of side angle side. Our angle is in between the two sides. Number 11 is side angle side. For number 12, we've got some parallel lines. I also know I have that reflexive shared common side, so I always look for the reflexive side. And then our parallel lines. So first set of parallel lines, AC is parallel to BD. So if I connect them, I make that Z shape. Remember, it's the angles inside the Z that would be equal to each other. So I can say angle here in this corner, ACB would be congruent to DBC. That's the Z that's created there. And then you could also create a Z going in the opposite direction. I'm going to erase this Z just because it might confuse you. So the other Z would be these two sides. AB, that's the statement here, is parallel to CD. And if I connect those, and it's almost creating like a little upside down rotated Z. And so my angles that would be congruent because of that are these angles here. Those are the other alternate interior angles. All right, so I'm going to take away my Z's. It might be confusing. And then we can say, okay, well, we've got an angle marked, we've got a side marking, and we've got an angle marked. And that side is in the middle of both angles because if I trace out the full side, it connects to both angles. So this is angle side angle congruency. And we're on number 13. We've got a mark here for an angle already. We've got a mark here for another angle. There's no vertical angles and there's no reflexive sides. So I just got to use this other given information. C is a midpoint of AE. So when you're a midpoint, you make two parts equal. I can put my side marking there. And if I think about that side doesn't connect to this angle down here. It's not in the middle. So that would be angle, angle side congruency. And then we've got here on 14, we've got our right angle marked here. So I'm going to put another angle here. Vertical angles, remember the bow tie. And then if these lines are bisecting each other, it means they're both being cut in half. So this line here is being cut in half. So I can put the congruent marks on it. And the other line is also being cut in half. So I can put the congruent marks in it. Now we don't necessarily know that all four of those parts are equal. So what I can do is just put 2 marks on the other one. Okay, so then we've got here a side, we've got an angle, we've got a side. I know sometimes if you have a right triangle, you want to look for hypotenuse leg, but technically this side here is hypotenuse and it's not even marked. So we do know that it's side angle side, and that angle is in the middle. It's between the angles and between the congruent sides. So that would be side angle side. Okay, and then we've got here we've got CB bisecting both of these angles. First, it's bisecting DCA. That's the angle here on the left. So DCA, I'm going to put the congruent mark here in the angles. It is also bisecting DBA, that's this angle here on the right. So I'm going to put 2 marks on it. And then always look for that reflexive common side. So this will be angle, side, angle congruency. That side is in between those 2 angles. Angle, side, angle. Okay, so now I'm going to look at, we've got our congruent statement. So this is question number 16. So we have triangle CFE, the order that those letters in should be matched up. So that means C should match up with angle P, F should match up with angle T, and E should match up with R. So anytime we're using the letter C, we want to replace it with the letter P. So if you look, for example, here we've got CE, so I'm going to replace C with P. And we're replacing E with R, so PR. Or you can also look kind of at the order that the letters are placed in. And then we've got TR, middle letter, last letter, that's going to be FE. We've got CF, that's first letter, second letter, that would be PT, first letter, second letter. Now we're going to match up angle P. Remember, angle P goes with C. Angle E goes with R. And then angle F goes with T. And then we want to complete our triangle congruent statements to make sure they're accurate. So we've got R, P, T. So R matches up with E. P matches up with C. And T matches up with F. And then if I did FEC, that's first or second letter, last letter, first letter. So it'd be TRP. TRP. And then our last one is RTP. So that would be, I'll just do the letter here. R matches up with E. So triangle E. T matches up with F. And P and C match up with each other. Okay, so on Edge Elastic, you're going to need to drop and drag this. Now, the issue is sometimes these images are a little too big. So I'm going to click Control minus to minimize the screen so I can see everything. You'll notice here it's kind of resetting so I can see more of the screen. Maybe I'll make it just a little bit bigger here to 90%, or Command minus sometimes makes that a little smaller as well. So remember CE, now we're just dropping and dragging. So remember CE, first letter, last letter matched up with PR. There we go, PR. So I'm just dragging it into that. And then we've got TR, that should match up with FE. And then we've got CF matching up with PT. All right, and then angle P matches up with C. We've got angle E corresponding and matched up with angle R. And then we've got angle F corresponding and matched up with angle T. And then with our triangle congruent statements, we have RPT, we said RPT, that would be ECF. So ECF, here we go. Match that up. FEC, that would be TRP. TRP. And then we've got RTP. RTP last second would be EFC. See, there we go. All right, next question. So the next one, we're also going to be kind of doing the same thing. I'm going to use my diagram here to make sure I match up. We know these triangles are equal or exactly congruent. So that means angle D and angle G are going to be the same exact number. So I have angle D here is 34, and angle G I'm also going to put, I'm going to zoom in just a little bit, 34. And then to find the last missing angle, we're going to do 180 minus 105 minus 34 degrees. Remember, that is the triangle sum theorem. So we've got 180 minus 105 minus 34. And that should be 41 degrees. So I'm going to place 41 here degrees. And that means J, which is the middle letter, matches up with E, the middle letter. So I'm going to put 41 degrees here. And then our last angle should be the 105 degree angle. Okay, so now we have all our angles kind of listed out. And then in terms of sides, side EF is 14. EF, that's going to match up with JH. So this side will also be 14. It's between the 41 and 105 degree angles. And then we've got our side length HG. HG should match up with FD. So this side here should be 16. And then our DE side is 19, so we've got 19 here. So we should be able to kind of match those up. So we know that DF is going to be 16. JH is 14. 16, 14, and GJ is 19. So 16, 14, 19. Let's put those in. And you're just going to type them. So 16, is that what we said? 14, 19, yeah. These you can just type in. And let's put our angles there as well. So angle F, we labeled as 105 degrees. Angle G, we said was 34. And angle J is 41. So 105, 34, 41. Okay. And now we've got some flow charts. So I'm going to go through these flow charts with you here on my packet, and then just show you how you can kind of drop and drag those into your answers. I'm just going to do that for number 18, and then 19 and 20, I'm just going to do directly on this paper here. So for this proof, all my given information is on the actual diagram. So that's great. We don't have any boxes that come above that. So we can start with really any piece of information that we want. Sometimes I like to look at my triangle and make sure I know why they're congruent to each other first. Remember, this is a side that's marked, this is another side that's marked, and this is an angle. So it could be side angle, or it could be side angle side, and maybe it could be hypotenuse leg, because it is a right triangle too. So the way we determine that is, well, this is an angle, this is a side and a side. So this is side angle technically. That angle is not located here. It's not in the middle. So it is side angle. Side angle doesn't prove congruency. So then I say, okay, well, is this hypotenuse leg? Well, it's a right triangle, and here's a hypotenuse, and here's a leg. So it is hypotenuse leg. So that means I need a congruent hypotenuse, a congruent leg, and I need a right triangle statement. Okay. So congruent hypotenuse could be BC is congruent to EF. That was given. It's marked on the diagram. And then we've got here, so those are the hypotenuses. We can do AC. That is congruent to AC. I do DF. That's also given. And then here we have a right triangle statement. So I would say, which is given. We could say triangle. I'm going to put this up here a little bit because I write too big. Triangle ABC and triangle ABC and DEF are right triangles. Now we can prove what we were trying to prove, that the triangles were congruent. So that's ABC is congruent to triangle DEF. And that's because of the hypotenuse leg congruency. So back onto Edge Elastic, we've got a congruent statement about their sides, AC and DF. And so remember, that can actually go into any one of those three boxes. Okay, the other congruent side statement is BC and EF, and that also can go in any one of the three boxes. And then we have a right triangle statement. So they are right triangles. That went here. We can technically switch those around. Oops. There we go. And then we know these are given information. So given. And we should be able to bring that up again. Given and given. And then we know the triangles are congruent. That's this prove statement here, A, B, C to D, E, F. And we knew the reason for that was the hypotenuse leg. Oops, let me put that back in here. So you might have to try a few times, make sure it fits in there. And then we've got hypotenuse leg. And look at here, we've got right hypotenuse leg, HL. So that's a reminder that has to be a right triangle. And sometimes if you can't get each piece to drop and drag, probably might need to zoom out one more time. Now I can move it properly because it needs to all be fit in the window. Okay, so then you can click on next. All right, let's try this on the packet first. Or actually, let's just try this on here. So we've got B is the midpoint of AC. So I'm going to use my little scratch tool. This is the midpoint of this entire line, AC. That means both parts of the line are equal. So I'm going to mark them equal because of that midpoint. I also know in this given information that AD is congruent to CD. Let me put 2 marks on that. And then the side that they have in common, this is the middle side, that would also be congruent. I'm going to put 3 marks on that. So your marks don't have to look identical to mine, but they should be unique, meaning one set of sides that has 1 marking, another set that has 2, and then maybe another set that has 3. So your first part to the question on edge elastic, which you're going to do on the test, is making sure your diagram is marked up properly based on given information and then the properties that we know. Okay, so now we can start dropping and dragging into our proof. So the first thing is, okay, well, we know these triangles are congruent because they've got 3 sides. So I know my middle part to the proof has to be some congruent statements here. Okay, so first given, B is the midpoint of AC. Well, that doesn't say congruent, so that can't go in any of these middles. It has to go at the top. What that does tell me is that parts are equal. So this was given. I know that B is the midpoint of AC, and because that, I figured out that this part AB was congruent to CB. So let's look for that statement. AB congruent to BC, yes. AB, so that's this part here, whoops. AB congruent to BC, so these 2 parts here. And that's because we had a midpoint. So I would say definition of midpoint. Definition of midpoint. Okay, now the other 2 things, so the other sides that we said were equal, well, one of them was given. AD is congruent to CD. So AD congruent to CD. That was in the given information. So I'm just going to move up this given here. And then that last side that we said was equal, that's a reflexive side. Shared common side between both of those. We call that BD, and we said it was equal to itself, BD. And that's the reflexive property. So we'll move that up here. Now we know the triangles are congruent. This will go in here eventually. There we go. The triangles are congruent. So we've got our statement here. And we'll drag that in. And we said they were congruent because of their sides. That would be side, side, side congruency. Okay, and that's question 19. And then our last question, number 20, and we'll just do these last 2 on edge elastic. All right, so we've got our scratch pad, we've got some given information. So we've got line QR is parallel to ST. So if those lines are parallel, remember anytime you have parallel lines, you are making an F shape or you're making a Z shape with alternate interiors. So I'm going to create the F shape out of these. And I'm going to place congruent angle markings, an angle Q, or we can call it RQS, and angle TSU. The other angles that are congruent, we have another set of parallel lines. We have RS is parallel to TU. Now, if I were to connect those, it would be like a backwards upside down F shape. And these would be the corresponding angles that are in the F shape that are congruent. Okay. And then the last part that we have here, let's see, maybe green, we've got this statement QS and SU. So here is QS and here is SU. So you don't need all those extra lines that I highlighted. I just use that to help me figure out that that's where I should place the angle marks. So really we just need the angle marks here in the corners. So here we've got an angle, we've got a side, and we've got an angle. So we know these are congruent because of angle, side, angle. Let's go down into our proof here. So we had a parallel statement. QR is parallel to ST. QR and ST, that was the first one. That made this angle here Q, or RSQ, equal to its corresponding angle. So RSQ TUS. Oops, does it let me move it? Yes, it does. Oops, it made those equal. Yes. So we know that the first part was given, and then the angles were congruent. RSQ. Oh, those are the wrong angles. Let me move that back down here. So we need RQS and TSU. Let me get the right ones. RQS, TSU. Here we go. Zoom out just a little bit more. So we need RSQ, and we're looking for the angles. RQS, rather. RQS is congruent to TSU. So that was given. And the angles are congruent because remember we created the F shape and that is corresponding. So I'm going to put corresponding angles. I'm going to just move this up to this box here and then see if I can, oh, there we go. I almost got it. Move it over. There we go. Corresponding angles. Then we had our other parallel line statement. So we had RS and TU. So RS and TU. That made the other angles at the corners equal. RS and TU. The other angles would be TUS and RSQ. So TUS and RSQ. We've got to move that one up. And the reasons for those should be the same. So we've got given, the parallel lines were given, and then those angles were equal there because they were corresponding angles. Okay. And then the last part was this given information. QS is congruent to SU, so I can just drag that here, and that was given. And then based on the marks that we had on our diagram, we should be able to prove the triangles are congruent first. So let's pull out a triangle congruent statement. So we only have one triangle congruent statement. So the triangles are congruent because remember the marks in our diagram is angle, side, angle. So we'll drag up angle, side, angle. And then therefore the parts would also be congruent. So we're looking to prove these parts are equal. And if the triangle is equal, their parts are going to be equal because they're corresponding. So we'll do angle QSR and STU. STU. So this is the proof part, which always goes at the end of the proof. And that's because their corresponding parts of congruent triangles are congruent. CPC. TC.